Hello everyone, in this video I discuss how to compare different forms of integration. So while doing the methods of integration we have discussed different rules like the general power rule or the logarithmic form or inverse sine form, inverse tangent form. So all these can be really confusing. So I have made a list of problems that we will discuss that what rule applies to what problem. Let's take a little review of what the different forms are. So we discussed that if you have u is equal to fx and if you have u raised to power n du, so in that case you increase the power by 1, divide by the new power plus c. And we also did the other form of the same equation, which is if you have integral of fx raised to power n f prime x dx, so which means you have a function raised to power n and differential of the function, then the integral is you increase the function power by 1 and you divide with the same new power plus c. And when we did this, we know that n should not be equals to -1. So it means you cannot have the power of the function 1 in the denominator. Similarly, for the logarithmic form, so we deal with that case when n is equal to -1, or in other words, the power of the function is -1, so u is in the denominator. So in that case, if you have reciprocal of a function and differential of a function, so integral is ln of absolute value of u plus c. Or in other words, you can say that integral is integral of 1 over fx, and then on the top you have differential of fx is equal to ln absolute value of fx plus c. So this is our general logarithmic form. Similarly, for the inverse sine form, so if you have u, so in terms of u, so if you have integral of du over square root of a square minus u square, so that would be sine inverse u over a plus c. So the other equivalent form is, so if you plug in u is equal to fx, you get 1 over a square minus square of fx square, square root of the whole thing, and then multiplied by differential of fx. So this would be sine inverse fx over a plus c. And last one is we have inverse tangent form. So in this one, if you have du over a square plus u square, so that is our inverse tangent form. So tangent inverse u over a and also 1 over a plus c. So in this case, you can have the equivalent form in which you can write. So if you plug in u is equal to fx, you get 1 over a square plus fx square, and then you have differential of fx. So the answer would be 1 over a tangent inverse fx over a plus c. So these are the 4 basic forms, and now I'm going to discuss some problems in which we're going to recognize one of these forms. So in the first one, we have 1 over square root of 1 minus x square dx. So this is our form, the sine form. So if you compare the formulas on the previous slide, so sine form, so it means our answer should be sine inverse x plus c. In the next one, we have the same thing in the denominator, but we have a factor x in the numerator. So this is not an inverse sine form. So in this case, we can see that we have a function in the denominator and the power of the function is -half overall, and we can make the differential of the function as well. So this is a general power form. So we can rewrite the function as 1 minus x squared raised to power -half, and then we have x dx. So if you want to make the differential of this function, you need a -2 here. So it means also you need to divide by -2 to compensate for the -2 that you added here. Using the power rule, the answer should be increase the power of the function by 1, so it becomes half, and divide by the same new power, and then we have -1 by 2 outside plus c. Therefore we got square root of, so negative outside 1 minus x squared plus c. Now let's look at part C. So there is a subtle difference between part B and part C. So we only have no square root in the denominator, rest everything seems to be same. So in this case, you will notice that here, if you consider the function 1 minus x squared, the power of this function is -1. So whenever you have the power other than -1, and you have differential on the top, we have general power form. But in this case, since you have the power -1, so this is your basic logarithmic form. So here we can rewrite the function as, so we have 1 over fx, and we need the differential of that, so x dx. So differential of this would be, so we need a -2 here, and we're going to compensate for that, so we're going to divide by -2 as well. So now we have reciprocal of a function and the differential of function. So using the logarithmic form, the answer should be -half is outside, and for this integral we get ln of absolute value of 1 minus x squared plus c. So in the next one we have dx over 1 plus x squared integral of this. So we can just recognize that this is inverse tangent form. And in this case, the answer should be tangent inverse x plus c. Similarly, in next one, we have the power of function 1 in the denominator, and we can make the differential in the numerator. So it means this should be our logarithmic form. Thus here we can make 2x dx, which is differential on the top, and we have 1 plus x squared as our function, and since we added 2 here, we need to divide by 2. So now we get the logarithmic form, so it should be ln of mod of 1 plus x squared plus c. This one we have x dx over square root of 1 plus x squared. So we have power of a function which is power is other than -1, and we can make the differential of the function. So this is our problem of general power rule, and you can solve it. So let's take a look at the next one. So again, here we have a function, and the power of the function is -1. So it means this is our logarithmic form. So logarithmic form. So I'm just gonna sort the forms so you can write your solutions later on. Similarly, if we look at this one, so we have 1 minus a perfect square root of that, and we have differential of, we can make the differential of that on the top. So I'm just going to rewrite this as, so we have x dx, and instead of writing 1 minus x raised to power 4, I'm going to write x squared whole square. So if we notice that this is like function square, and this we can make the differential of the function on the top. So we add a 2 here, and we can also divide by 2. So our integral becomes this. So this is a form which resonates with our inverse sine form. So you have differential of the function, square root of 1 minus square of the function. So this is our inverse sine form. Therefore, the answer should be half sine inverse function, which is x squared, over a, which is just 1, plus c. Again, in the next one, so we can make the differential on the top, and then we have 1 plus square of a function. So this is our inverse tangent form. Inverse tangent form. So we can rewrite this as, so 1 plus x square, square of that, and then we can make the differential of that x square on the top. So since we have added a 2, so we need to divide by 2. So overall we get half tangent inverse, and we have x square plus c. Therefore, it's very important that you recognize the correct form and don't confuse this with the other forms that we haven't done yet. So there are other integrals who appears to be similar, but they do not fit the forms we have discussed so far. Fully analyze these problems and do not mix them together. Thanks for watching. I hope you enjoyed this video.